Today we'll be learning how to actually write the equation of a line in slope-intercept form. We're going to use different information so that you can write it when it's in any situation. So I don't have anything written on the left-hand side, so when you have your left-hand side, what I'm expecting you to do is to write down any explanation that I have, that I say, that will help you get the questions on your own. You often say that you get it in the notes, but you don't understand what to do when you go to the practice. Well, this is where you're supposed to expand so that you can look back at your notes and use them as a guide. So go ahead and write down today's title and date, and then separate your page left side, right side. Example 1, write the equation of the line in slope-intercept form from a graph. So the first thing that we want to do is identify the information that we have. I have 3 different coordinates. And then I also notice that my line has a positive slope. So I kind of understand what my equation will look like. Now, one of the coordinates that I'm given is actually my y-intercept because my x value is 0. So all I have to do is figure out my gradient or my slope, and I'm going to go from 1, 1 to 2, 4. 1, 2, 3. I went up 3 and right 1, which means my gradient is 3 over 1, which means my equation is y equals 3x minus 2. Same thing again. I'm going to identify what I have. I have I have negative 2, 3, and 1, negative 1. And I notice that my line has a negative slope. So I'm going to figure that out first because I don't have my y-intercept. I know my y-intercept is here, but I don't know what that value is. And instead of assuming that it's something, you have to figure that out mathematically. So going from negative 2, 3 to 1, negative 1, I go 1, 2, 3, 4, down 4, and 1, 2, 3, right 3, which means my gradient is a negative 4 over 3. And now I'm going to use one of these coordinates that's given. So I'm going to use this one because the numbers are smaller. And I'm going to assume that the 1 is my x and the negative 1 is my y. So when I plug those in to my equation, y equals mx plus b, I'm going to say a negative 1 equals a negative 4/3 times 1 plus b, so I can find my y-intercept. A negative 4/3 times 1 is a negative 4/3. I'm going to add 4/3 to both sides. So it cancels out, and I get b on my right. And then I take a negative 1 and I add 4/3. A negative 1 is really a negative 3 over 3. I want to do that so I have a common denominator and I can subtract these fractions. Negative 3 plus 4 gives me 1 over 3. So my b is 1/3, which means my equation is y equals a negative 4/3 x plus 1/3. I said a lot there, so please make sure that you put some notes in the left-hand column so that you can do this on your own. Second example, write the equation of the line in slope-intercept form from 2 coordinates. So the first thing I'm going to do is figure out my gradient or my slope. So I say that the gradient is equal to, remember, y2 minus y1 over x2 minus x1. And I suggest you label your coordinates so that you don't get confused. So I say 3 plus 1 over 5 plus minus 0, which gives me 4 over 5. And since this coordinate has a 0 for the x, that tells me it's my y-intercept. So I can say y equals 4 over 5x minus 1. I'm going to do the same thing again. I have my x1, y1, x2, y2. And I say m is equal to a negative 7 plus 1 over a negative 4 plus 2, which gives me a negative 6 over a negative 2, which gives me 3. And then I don't have my y-intercept, so I'm going to use the smaller numbers to find it. I'm going to say a negative 1 is equal to 3 times a negative 2 plus b. That's a minus 6 plus b. Add 6 to both sides. I get b is equal to 5, which means my equation is y equals 3x plus 5. Last set of examples. Write the equation of the line in slope-intercept form from a table of values. So here, what I want to look at, I can do this one of two ways. I can use the slope formula again, y2 minus y1 over x2 minus x1, or I can look for a pattern. I'm going to look for the pattern in my table. Going from x, 1 to 2, I plus 1, 2 to 3, I plus 1, 3 to 4, I plus 1. That's the same pattern. For y, I minus 6, minus 6, minus 6. That means my gradient is a minus 6 over a plus 1, or just a minus 6. And again, I don't have my y-intercept, so I'm going to choose the smallest numbers and plug those in. I have a negative 3 equals a minus 6 times 1 plus b. That's a minus 6 plus b is equal to a negative 3. Add 6 to both sides. I get 3 is equal to b. So I have y equals a negative 6x plus 3. Last example, I'm going to do the same thing. On my x, I go up 3 each time, just making sure that that's consistent. And then on my y's, I go up 2 each time. So that means that my gradient is 2 over 3. And again, I don't have a y-intercept, so I'm going to use the smallest coordinates and say 2 is equal to 2/3 times 3 plus b. I get 2 is equal to 2 plus b. Subtract the 2. I get 0 equals b, which means my equation is y equals 2/3 x. Please make sure that you ask any questions that you have for clarification, that you go ahead and work through some questions on your own, and then come back and write a reflection.